All right, my name is Henry. My lab partner is Armani. What our project here consists of is basically an autocorrelation simulation. Basically what that means is we're going to have two signals come in, basically autocorrelate with each other. As you can see here, this is pretty much our setup, our hardware setup. We have a laptop. We have a Bluetooth adapter on the laptop. We're using that one so we can basically create in a sense, a virtual COM port. Since we're not using any wires, we are using UART, which is what the Bluetooth adapter is based off of. Over here, as you can see for the FPGA, we're using the Spartan-6. Behind it, or attached to it back here, is the Pmod Bluetooth adapter. And the software that we are running is essentially a hyperterminal. The Windows XP hyperterminal works just as well, but we're using this one because we can pretty much do different settings, just like hyperterminal on XP. But here we have it visually; we can see what's going on if we need to make any changes. At the same time, we're messing around with the auto send. We can send whatever character, and it can repeat basically to the FPGA if we needed to. But in our case, we only need to send one character. In other words, one signal. As far as the how it's going to work, my lab partner Armani will pretty much describe that and give you further instructions and details on how that basically works within the FPGA.
Alright, so on the FPGA, right now it's simulating as the receiver. On the right side of the 7-segment display, there is a hex code being displayed. That is the replica PRN for the receiver, and this always runs. On the left side, that will be when the satellite signal, the signal simulated from the laptop, is shown. And when they match, that's when we have the autocorrelation. So, without further ado, we will begin the demo.
Okay, so as you can see, that the Spartan-6 is already running our program. On the left side, we have we have a seven segment. The left two sections of the 7 segment, you can see basically a numbers just running. Basically, that's the simulation sequence of the simulated signal. On the left side, you see the other 2 zeros there. The 2 zeros is basically waiting for our signal to come in. So once we get our signal coming in, and then the two, or basically the 7 segments, the 2 left and the 2 right, will match and will basically simulate an autocorrelation. As you can see, we're wired right now. So let me take this off. We have the Bluetooth adapter is working. We're paired up with the Bluetooth adapter on my laptop here, and we're using the UART to communicate to the Spartan-6 as mentioned earlier. So basically all I'm going to do now is have a character here. I can type anything, it doesn't matter, it's just a signal. So what we're going to do is we're going to do a manual send. Once we do a manual send, it will send the signal out to the Spartan-6, and you will see the 2 double zeros will change. It'll change to E9, that's our signal. Once our signal is displayed on the 7 segment, the right side of the 2 7 segments on the right side, as you can see scrolling, will keep on scrolling until it finds a match. And once it finds a match, it's basically, as I mentioned before, an autocorrelation. But then the right side will continue to keep scrolling, because once it makes an autocorrelation, it doesn't mean that it stops right there. It's going to continue sending a signal and continue to find a match every time. So here I'm going to send a signal right now. Okay, signal sent. As you can see, the left side, you have E9, which is the signal we sent. The right side, it's scrolling. Every time it sees an E9, that basically means an autocorrelation between the 2 signals.
So that was our demo for our autocorrelation project. Thank you for watching.